Hello everyone, I am Umair and you're watching Chemistry Guides. This video is part 3 of the topic detection and measurement of radioactivity. In today's video, we will discuss about gas ionization methods for the detection and measurement of radioactivity. So we know that when radiation passes through a gas, some of the energy from the radiations transfer to the gas molecules, which may cause the gas molecules to be ionized into positive ions and electrons. But these positive ions and electrons have the ability to recombine. So if we apply the electric field, these ions and electrons can be collected before they get the opportunity to recombine. So as a result of their collection, we get the magnitude of resulting current, which the magnitude can be correlated with the amount of radiations initially responsible for the ionization of that gas molecules into positive ions and electrons. So this is the diagram of some sort of ionization chamber. What is ionization chamber? It is actually a device in which an electric field is applied just sufficient to collect all the ions and electrons produced in the volume of a gas between the electrodes. If we talk about a common gas ionization counter, it will be Geiger-Muller counter, which you can observe in the diagram. This is also an ionization chamber. If we talk about its construction, it is consist of a cathode which is cylindrical or tube-like, while a thin tungsten wire which is fixed on the axis of the cylindrical or tube shell serve as a node. So the radiations enter the tube through a thin micro window made of mica. So first what is happened is the tube is filled with the gas. The gas usually is argon gas at very low pressure. Further, the working potential of 1200 volts is applied between the inner wire and the outer tube. I mean cathode and anode. Inner wire is anode and outer tube is cathode. So when the ionizing radiations enter through the thin mica window, they interact with the atoms of the filled gas to produce positive ions and electrons. So we have now positive argon ions, Ar positive. Because of their positive charge, they will move toward cathode, and the electrons, because of their negative charge, they will move toward anode. So during their movement, the counter generates a pulse due to the free electrons. This pulse can be amplified from each ionization. It can cause a clicking sound in a loudspeaker or activates a digital counter to register the amount of radiations entered in the tube. We can also attach a chart recorder to give a graphical display of the intensity of radiations versus time. This counter is generally used for the detection of beta and gamma rays. However, if we modify this counter, we can use it for the detection of alpha particles, photons, neutrons, and X-ray photons. There are some merits and demerits, limitations of Geiger-Muller counter. First, if we talk about the merit, this technique is very sensitive. It produces the pulse size is independent of the nature of incident radiation. Geiger-Muller counter produces large pulse which requires no further amplification. So we don't need any further amplifier for the amplification of pulse. If we talk about the limitations of Geiger-Muller counter, it is not very sensitive for very high counting rate. So we can count only small rates. Geiger-Muller counter is unable to give information about the nature of particles detected. We don't get to know what is the nature of the particles emitting radiations, ionized radiation.